For this session, I encourage you to go ahead and drop your questions in the Q&A box. There will be a Q&A section. Please post your questions during this session there, and we'll get to them, answer them. In addition, join us on Slack. We have a dedicated channel where you can ask questions about this particular series and keep the discussion going. That channel is the hashtag build-a-ds-projects. Please go ahead and join us on this Slack channel where you can continue to stay engaged and discuss topics around this series. So without further ado, I am going to introduce our wonderful speaker today, Lindsey Robertson. She's an analyst and CRM manager at iKadre. It's an M&A advisory firm focusing on pitching, positioning, prospecting, and integration projects for clients. With experience in strategic management, ops management, and P&L accountability, she started her freelancing business in analytics, CRM, digital marketing, and data management. Now she helps small businesses improve brand perception, market reach, and revenue operations. Lindsey completed a career track bootcamp in data science, and she continues to grow her capabilities in ML and predictive analytics with the WWCode community. She's interested in philosophy, consciousness, AI, and building a community with people who love data. And we are also so fortunate and blessed to have her as a lead of our track, of the data science track. So thank you so much, Lindsey, for being so involved in our community and for being our presenter today. And I'll hand it over to you at this time.
Thank you so much. That was such a nice, warm welcome. I really appreciate everything that all of the volunteers on this call have done to make this series happen. So let's not forget to give all that credit to all the hard work that went into preparing the materials and to just making the live events run. So I appreciate you all as well. Okay, let's go ahead and get set up to share my screen here. Okay, excellent. So you all know about me. I'm really happy to be here. And just like everyone, or mostly everyone on this call probably, I started from no knowledge about data science or a technology background. I had a business background, and I was just really curious on how we can leverage data in decision making because I was a decision maker. So I kind of like exploring details, and I'm a very curious individual. So that's how I ended up wanting to learn data science. And I did not take the academic path. I took a boot camp. And I learned with online sources like many of you are probably doing now. And I'm really excited to kind of get you into learning how this approach and how the data science process works and the methods behind how we build a project. So I'm going to discuss the series agenda first. And what we're going to do is, just develop your machine learning toolkit to solve difficult problems. And reinforce the intuitive decisions that you need to make sometimes. So data kind of helps us with these decision-making challenges we come across that have been, traditionally in the past, just like I said, relied on intuition. So it kind of just boosts everyone's toolkit. Any profession can benefit from this, this technology. Like I mentioned, I started from not knowing much about technology, programming languages, or data science, but I firmly believe that anyone can become a data scientist. It doesn't really often require a team. You could work on your own on a project, but sharing ideas is important. So it's good to find a community to do that in. But tools are often open source and data is becoming more and more accessible. So I don't see a reason why hobbyists and novice practitioners can't get started in the field. So the flow of the series is meant to mirror the steps or stages of a data science process. So this is what we're going to work on over the next 6 weeks. As you can see here, we're going to talk tonight about the introduction. Next week, we'll work on EDA, which is exploratory data analysis and visualizations. So presenting data in a visual manner. And we have some really talented practitioners, machine learning engineers, machine learning professionals, and data science professionals that have worked to kind of help you bring you some of this material. The following week, we'll work on data wrangling, or data cleaning as it's known, and feature engineering. After that, we'll do the baseline model building. So where we kind of just establish a minimum viable model to start seeing how we can improve. And then increased model complexity. So at the very end, we'll talk about making a model that's going to give us the results we're looking for, and how we can kind of gauge whether or not it's met our criteria for success, and what metrics we might use to gauge that. The sixth session will be really all about the participants. It's going to be participant-led, so we're going to discuss, your learning outcomes and things we can do to improve the work you've done and to make it more valuable. So that'll be really exciting, and we look forward to sharing that with you. Just a word of advice. This is an enormous topic. It is so vast, and what we're presenting is one of the most basic problems and approaches to learn. So you shouldn't be intimidated. This is just the tip of the iceberg, though. So when it comes to data science and machine learning, this series is designed to have you start at zero. So we're assuming you know nothing, and you can learn the minimum skills to apply to future studies. So if you start on this learning path, it's best to accept that learning will never end because there is far too much to master, and the rate at which technology changes is progressing too fast. So just get in that mindset of constant learning. It's a good thing to adopt early on if you go down this path. Also, I already mentioned that we, had some practitioners, some professionals that put this material together for you. So there's a big community of help should you have any questions, and the Slack channel is going to be the best place for you to go to get those questions answered as you leave the session tonight and you begin kind of working on your project autonomously. So our data comes from Kaggle. It's a great resource for finding public data sets for your data science projects. And this is the first place I would recommend anyone go, because there's a wealth of information as far as where the data set comes from, who's put it there, what they've done with it themselves. Sometimes you can find other notebooks of people's work that you can get inspiration from. And it's just really organized. A lot of times too, you'll find nice and clean data. So in the real world, we don't always get clean data sets, and most of your time is spent cleaning it and preparing it so it can be used in models, which is actually a really tedious job. The nice thing about Kaggle is it offers really clean data sets you can just kind of plug and play, so to speak. So it's great for beginners. There are a lot of other public data sets. So perhaps in another session, we can kind of dive into those. But Kaggle is a great place to start. So our specific data set is going to be exploring basic attributes to collect information on choice or preference to make a recommendation. So we're going to look at Spotify song attributes because that's a topic that most of us like, music, and something we can all relate to. Do I like it or do I not like it? And I'm just going to bring this up real quick. Can we all still see my screen? Good. Okay, so if you look through Kaggle, you can get all the information about the data set here. And what we're looking at is a bunch of song attributes that have 16 different features. So different aspects of the song. And then there's also 2017 observations. So if I go down here, I think it'll show me that. And that tells us that that's how many rows of data we have, how many different observations we have in our data. I'm trying to find where it says that, but if you, here we go. That's
Lindsey,
how much.
I have a request, sorry to interrupt you here, a request to possibly make it bigger. Anyway, we can make the screen bigger so we can see the text.
Let me go back here. Is that better?
Maybe you can, if you go to the Kaggle, you can probably do a Command plus or Control plus pen.
Okay.
Make the screen bigger, make the text bigger, maybe.
Yeah, let's see here. There we go. So just get familiar with this platform, spend some time on it. It's well worth the time. Click through it. And like I said, if you click on the code part here, you can find other people's work to get inspiration from. And that's also a really nice boilerplate. So as I mentioned here, we have songs, attributes, 16 different attributes of the songs, and 217 songs or observations of whether or not they liked it. So they labeled it a 1, or each song is labeled 1 for like it, yes, and 0 for don't like it, which makes sense to me. So you'll understand what that means, label, as we continue the talk. So let's go back here. Let's see. Oops. Bear with me here. Okay, so for tonight, our agenda, I think I got my slides mixed up, but I just wanted to say really quick, we're going to look at the data. So we just took a look at where the data comes from. We downloaded it from Kaggle. That's where we got it. And we saved it on our local machine, hypothetically here. Then we're going to kind of take a look at the problem statement overview, which is the most important part for the foundational work you need to do to create a data science project. It really helps you think through all the particulars, how to define what your success criteria is. And it's just a really good habit to get into to kind of develop use cases and valuable use cases that will, make more sense for either a stakeholder or a user in the end. So kind of reverse engineering what the outcome is that you want. And then we're also going to look at the project requirements for this particular project and do a review of the setup. So I'm not sure how everyone did on the prerequisites or if you needed the prerequisites, but we'll do a quick refresher on the most important parts of that. However, we won't be able to get you up to speed on coding, but there's plenty of resources on the Women in Code YouTube channel. There's a playlist there with the prereqs that you can review. There's also a nice checklist and a resource bank on the GitHub repo. So then we're going to load the data and then we'll save some time for Q&A. Okay, data science is a discipline for problem solvers, if you didn't know that already. It's a tool for any curious professional or decision maker that wants a competitive edge on their experimentation, their products, or their decisions. As I mentioned earlier, when we apply data science to real world problems, the first thing we think about is what kind of data science problem is my real world problem? And by that, I mean, we need to look at the types of common problems that are in the data science bucket or toolkit rather. We need to develop a data-centric problem-solving mind and start to look abstractly at the ways we can accomplish our goals with data. So that's another thing we need to do. And once we can define the outcome we are looking for, we can start thinking about data resources available and sometimes start thinking out of the box on what data points we need or features or attributes, as I mentioned earlier in the data set we just reviewed. And first, let's understand some of the most common data science problems as you're seeing here on your screen and the models needed to accomplish them. So these slides will be available to you later too. Don't feel that you need to take all these notes. We're just going to kind of look through some of these and discuss them. So the problem type will be here on the left column, the description, and then the possible model solutions. And so regression is a type of problem that predicts a continuous target variable. So you're going to see the word continuous or discrete. So the difference between that is discrete is usually a whole number and a finite amount of numbers. And continuous is it's ongoing and it doesn't have to be a whole number. It can be decimals and it can be ongoing. It's not finite. So that makes a lot of sense there. So target variable, we'll discuss that in detail later, but the target is what we're predicting. And then a binary classification is predicting two discrete class labels. So I mentioned label earlier when we talked about 0 for not like, 1 for like on the songs in the data set. And when we're predicting two discrete class labels, that's binary too. So we're either predicting yes or no, true or false, like or don't like. And that's how the binary classification works. The multi-class classification, as the name suggests, is just when you're predicting multiple labels. So not just true or false, it's either A, B, C or A, B, C, D, and that's what a multi-class would be. Clustering is where we take, is a unsupervised learning technique where we take items and we use the algorithms in the model to group like items together based on certain attributes, and we can find similarities between them this way. And then anomaly detection, as you would assume, is coming up with unusual patterns or outliers in data sets. It's often used in cybersecurity. Time series is where we predict future values of events based on historical data. Recommender systems is, I think, the most common one that us as users or consumers are probably the most familiar with, as we run into those with Spotify apps and even, our retail shopping online apps that lots of people use these days to get customizable recommendations. You're also seeing it on Netflix and Amazon. It's everywhere. So The other ones on the bottom are kind of less important to our studies tonight, but also very common. Natural language processing. So as Chi mentioned, we're going to have that series, or we're in the middle of the series of large language models, which kind of which supply ChatGPT all the power it has as far as its AI capabilities, and that all kind of stems from natural language processing. And dimensionality reduction. So as I mentioned, the features of the data, the attributes of the data, these are all interchangeable words that you'll start getting used to. The different data points you have, right, on your observation. Dimensionality is how many of those features or observations you have. And when we have way too many of them, sometimes it's hard to derive meaning. So we need to kind of figure out which are the best attributes to use. And sometimes that's not always straightforward with our scientific mindset. We have to use the technology to tell us. So dimensionality reduction is a great model to run when you're trying to do that. So as you guessed, I'm hoping everyone kind of guessed that I was going to have you do it, but I blew it. What our focus would be tonight is going to be on binary classification. Hopefully that was all straightforward and you kind of figured that out for yourself. So moving on. Next, we're going to talk about our problem statement. So this is, like I mentioned, the most foundational, important piece of your project to kind of make sure that you're organizing yourself. It's a framework to keep your solution organized and meaningful. It's a good idea to explore your use case, as I mentioned before you start modeling. And by use case, I mean, why would it be meaningful to have this prediction? How could this prediction be used in a real life feature or real life product, or how can it inform a user or a stakeholder? And that's what I mean by use case. How would it be used? And then that way you can kind of reverse engineer, as I mentioned, a useful tool. So to do this, we have a six-step process, and it changes kind of depending on where you learn it, but the framework is pretty much the same. We're going to use this framework where we discuss the context. So why are we creating this project? What's our problem? What's the purpose of us creating this project? There had to be something that sparked the need for the prediction. So the pain point, right? The criteria for success is what will happen in order for us to know that we have a successful product. This doesn't necessarily have to mean the accuracy of the model or the performance of the model, so to speak. It can mean that we've come up with a minimum viable product that serves our context, that serves our problem. Scope of the solution. So we want to know, how far we're going to deal with the solution. What aspects of the problem are we going to address? What's the scope? And this is all great. This framework actually really fits well into a work environment. So if you're going to take your hobbyist studies into the work world, it's kind of great to remember this problem statement overview, because it'll help you interact well with your stakeholders, who is ultimately who you need to impress to be good at your job. So as I mentioned there, we're going to continue with the constraints. So when you're working in an organization, there's constraints at your organization. There also might be constraints in the project you're dealing with. All the time there's going to be constraints, because we work with very abstract, difficult problems as a data scientist. So where's the roadblocks and what's preventing you from achieving your success? Identify that. Also, like I mentioned, stakeholders are the important people who you want to impress with your solutions. So identify who those people are and how they'll help shape how you think about your solutioning. And then also the key data sources. As I mentioned before, you're going to start to think out of the box on where you can collect the specific data points on your problem that you need to solve the problem with. So hopefully that's somewhat clear. I know it's changes from situation to situation. It's very dependent on that, but this gives you a good framework to try to solve your problem.
Lindsey,
So
I wanted to call your attention to a question we got here in the chat,
Great.
Which was likely when you were looking at the different sort of types of machine learning models. The question is, or the different data science problem types. Someone asked, could time series also be defined as a chronological plotting of data? And they're trying to figure out if this is the correct way to think of this.
Yeah, it is definitely chronological. So it's like a forecast. It's exactly like a forecast. I think that you have the right idea. We're going to take historical information and we're going to project it into the future to see where it would end up at a certain point. I hope that answers your question. Okay. Problem statement. Okay, so we're going to do this together. Let's think through it a little interactively. We'll kind of move quick, but use your chat and don't feel, don't be afraid to put your ideas in there. Let's think about our particular problem with the songs, likes and dislikes from our Kaggle data set. What would be our context? Does anyone want to put in the chat what they think the context would be? And there's no time limit. We're just going to kind of move through this quickly. It was just a nice exercise to kind of get your brain jogged on what you think we might be achieving here tonight. And I don't have chat monitored. So if moderators or hosts wants to look at that and make sure we're getting some answers in there, that way I can know when to move on. That would be great.
Someone wanted us to also share the links in the Q&A, as a copy option seems to be disabled in Zoom. I wonder if people are having trouble. Can you guys click on the links? Is the link taking you to the right place? The person is asking to put the main message with links into Q&A.
Yeah, we can do that. Go ahead and place. Yeah, in the Q&A, go ahead and list as a question what link it is you're looking for, and we'll go ahead and pop them in there as an answer to you. If you're having trouble clicking on links, I can click on mine, but I'm not sure if that's just because I'm a host or not. Yeah, so I'm seeing some great results in here about the context. What is our problem? Maybe it's that we want to create a playlist. I know that there's a lot of easier ways to do this, but maybe we want to just have a playlist of all the songs there that only we like, so you need to put a label on the ones that you like, but you haven't gone in there yourself and selected like or dislike. So maybe that could be, a problem that we want to solve. So I'm going to go ahead and just populate the context for us. So, one of the aspects of the Spotify song recommendations, so on their app, one of their aspects of that recommendation engine they use is user data on songs that have been liked in the past. So we need to analyze the liked songs in order to know what similar songs users might also enjoy. This is a good contextual problem for a solution that might branch outside of ourselves. This might be used in a greater scale. Okay, so criteria for success. This could be pretty much anything. This is just you as a data scientist. What are you trying to achieve? Like I mentioned, it's not really related to how well your model performed, but basically if you were able to solve the questions you were setting out to answer. Go ahead and pop in the chat what you think your criteria for success might be here with our solution. And there's no right or wrong answers. We're just giving you an exercise so you can kind of start thinking like a data scientist. So as you're thinking about that, cool. Yeah, I see some good criteria for success here. All of this definitely makes sense. So I'll go ahead and pop this up here. Based on user Spotify data, can we predict a song will be liked or not? That's a good criteria for success. And then of course, we'll delve into metrics and understanding if the model is working or not, and to what degree it's working. And so that will kind of help feed into our success, but it's not exactly our criteria when we're just defining our problem statement. So I'm going to go move through this because the scope might be a little confusing for some, but we're just going to create a binary classification model to predict like or no like on songs. Our chosen solution scope does not create recommendations, but simply labels the songs to be used maybe further on in a recommendation system. So an extension could be to create that recommendation system later on, but that's not going to be in the scope of our particular project. Our constraints is data from one user does not include geographical data. Another one is that it's only based on one user. So applying that to many different users in a recommender might be a little tricky. That's definitely a constraint. We probably need to consider broadening our observations or more songs and more user data to do so. Stakeholders might be your product managers, your senior leadership, data engineers, users, anyone who's asking for your input on this data science project to produce a product. So data science is within this huge group of people that puts together a product that comes out, a finished, polished product that you can use. It's using machine learning in the background. Data scientists kind of help go through the data. They do the similar work to an analyst. They explore the data, they figure out how to clean it and how to use it and how to get it prepared for a model. They figure out which models to use that would be best in addressing the problem, and they create the models. And a lot of times, they work with data engineers to get them to connect the data they need, and they work with machine learning engineers to help deploy their code and to optimize their models. It's all a teamwork, but your stakeholders could be anybody on that team, or it could be the person who's simply your boss. But definitely users or stakeholders, because if you're making a product, you're going to want to consider the user. So the data we're using is historical user data on songs listened to and the reactions. Okay. So I mentioned earlier the target, and I said we would talk about it in a little more detail. The target is the dependent variable. So it's what we are predicting. And the target changes depending on what type of data science problem we're addressing. So in our problem, it's going to be categorical, which means it's not a number. Oops, I gave away the answer. That's okay. So if it's categorical, it's not numerical. It's a yes or no, true or false, but it could also be binary, or it could be numerical, 0 or 1. But the 0 or 1 has meaning to it. So that's why I said categorical outcome. And typically the labels, even if it's a 1 or a 0, like I said, there's a meaning attached to it. I think I just repeated myself, but hopefully that makes sense. And then on regression, it's going to be a numerical value, typically continuous, but doesn't have to be. And then also recommendation systems, the target would be a preference that you're recommending. So what is our target variable? If we're doing binary classification and categorical outcomes, can everyone just pop in the chat what they think our target variable will be? And the variable is also another name for feature, attribute, all of those things, dimensions, all those things that encompass the data points of our observation. Yeah, cool, you guys got it. So we're gonna do the song popularity, like versus don't like. That will be our target. Great. So today, we're gonna look at the problem and data, discussing building the framework for your approach and your solution. We're going to review quickly the setup for your project and on your machine and take a quick look at the data, which is what we did, but we'll also look at it in more detail. We'll load it for you here. And then the technology we're going to use to do that is the language Python, which is pretty common, but another common language that you might use or might be familiar with is R. And then also when you're doing your coding, and data scientists like to use what's called a notebook, which has different cells, sort of like a spreadsheet, but each cell has a different code block. And we usually like to do this because we want to organize the process. And we do that in a web application or an IDE. And there's many different ones you can use that you're comfortable with. Today, we're going to work with Google Colab, but others might include Jupyter Notebooks, Visual Studio Code, Spider, PyCharm, RStudio, there's many. But tonight we're doing the IDE or the web application Google Colab. So can I get a quick poll? I'm going to post a poll really quick for you. And I want to know just kind of everyone's familiarity and comfort with the coding language of their choice and the web app or the IDE of their choice. So you should see here on the screen, we'll take a quick minute so I can get a poll here. Oh, great. Okay, cool. Thank you so much for everyone who's doing the poll. This kind of helps me know what kind of pace to take through the notebook. It's great. We have some very skilled people here, which is going to be an awesome resource for us all. It definitely helps the conversation. It helps us out when we get questions that are hard to field. So that's great. Okay, I'll give you one more minute to vote. It looks like we have most people voted already. So I don't know, is everyone seeing the results or is it just me? Okay, I guess I'm the only one seeing the results of the poll. So as I end the poll, I'm gonna let you know that most of us, so we have 57% moderately skilled. We have 2% highly skilled, 33% somewhat new, and 9% total beginners, which is so exciting to see the total beginners here. This is what we wanted to do is make data science totally accessible to the very new beginner. Okay, I'm going to go ahead and end the poll. And I can share the results now. That's great. I didn't know I could do that. So I'm going to take a peek and I'll stop sharing. Okay. Next on the list here, we're going to do the Google Colab quick start. So we have a session 1 notebook started to load the data in, but what you're going to want to do is go to colab.research.google.com, and I'll put that in the chat for you. If I can, oops, maybe I'm having a hard time doing that. If someone can put that in the chat, that'd be great. Where you can go ahead and open a Colab. So get that going, and then we're going to walk through this real quickly. Once you bring that open, you're going to need to go to runtime and change the runtime type and adjust it to a Python version. So I'm going to show you, I'm just going to open my Colab document here. I'm probably going to need to blow this up as well. There we go. So we're going to go to runtime here, and then we're going to want to change the runtime type. And you're going to make sure Python is enabled here. And we do not need a hardware accelerator. That's if you're using GPUs or TPUs, which we don't really need to get into too much detail, but it definitely increases your performance and your capabilities with your models. So once you get really advanced, you can start using that. Okay, and then I'm going to do a quick overview of what you're looking at here. And if I need to slow down, please just put something in the chat to let me know. But I want to close this out here. Let me just go like this. Yeah. Okay, so what we're looking at here is different cell blocks, and you can see you have the option of using code or text, and text is really important. We use text blocks to do things like this, where we can give instructions. And when you're coding anything, whether it's for software or for data science, and you're getting started, it's important to know that you need to do good documentation, not only for you so you can remember your thought process, but if for someone else is going to work with you, collaborate with you, or pick up where you left off, it needs to be explainable so someone else knows what you were doing and understands your thought process, because there's so many different approaches to how you can solve this problem with your toolkit. So code and text. Right here, you see some text boxes, and then you'll see code boxes down here, which look a lot different. So I mentioned that already. We can import files, and you can share files, and you can export and save as well. It's pretty much self-explanatory. It's a great Google product. It makes it very accessible to start a data science project. So hopefully everyone's kind of on the same page here. Also, if you have not done so, go ahead and download the data from Kaggle. And you can download this button here and just save it on your local machine in a folder somewhere that's easily accessible. And then what we're going to do is we're going to load the data into our Colab notebook here so we can start doing some analysis on it. So go to this folder here on the left-hand side. And after you've downloaded the data, you can go ahead and upload it right here. And then you'll just plug it in to this session. So one thing to note is that you definitely want to have the most current version of the data saved to your local device, because the data will only stay here as on this session. Once you close out of this Colab, it'll save all the work you've done, but it won't save the data. You'll have to reload the data. So that's a good note to make. How are we doing on pace? I think everyone's keeping up pretty okay. So as we get started here, we're going to talk about, Colab, which we just did, coding best practices. We're going to review pandas and NumPy, and then we're just going to do a brief data overview and take a look at what we got there in that data set in the 2017 observations. So some quick coding best practices, and I think I might not need to do this in detail because we have people that are familiar with coding. But just a quick reminder, we're going to want to use meaningful variable names so we know what it is we're defining. Lowercase and underscores in between words is kind of a best practice. We can avoid using reserved keywords. So if it's the word we're going to use in our code blocks, we need to avoid using them as variables because that can create problems. Also, there's something called camel case, which we would have either a lowercase word and then an uppercase word if they are not separated by underscore. So you can differentiate the, multidimensional words, or you can do like an uppercase, like my class, as you can see there is uppercase my and uppercase class. That would be an example. Then also be consistent. So keep the naming conventions the same throughout your whole notebook. Use underscores, separate words. I've already said that already. And avoid abbreviations. So anything that can confuse you later on down the road, you think, oh, this is a great, variable name, but trust me, sometimes once you get in the thick of it and you have hundreds and thousands of code blocks or code cells, it gets difficult. So we're going to keep the function names concise, and we're going to use singular nouns for variables. Okay. All right, so now we can do a brief introduction to pandas and NumPy. Pandas is high-level data manipulation. So it's designed for handling structured data, so like tables that you're familiar with in spreadsheets. It's kind of that mindset. It also provides structures and that are flexible for data handling. So when you need to clean data, you need to transform the data, you need to manipulate it the way you need it for the model. Pandas is fantastic for that, and it's really easy to use. NumPy is the core library for numerical computing in Python, so it doesn't require a package install, whereas Pandas does. And it's for multi-dimensional arrays, so essentially like a list of objects or a list of values, but multi-dimensional. So it's like a matrix. Other efficient array operations and broadcasting of mathematical functions can be used with NumPy. So those are basically the two most common ways we can manipulate the data. So how we do that is I mentioned arrays and lists. So you can see the difference between arrays and lists here, and it has to do with, is it NumPy or Pandas? And then you can kind of read through the benefits of each. I think everyone kind of has their comfort level with what they like to use. It's highly objective, or highly subjective, should I say. Basically you can pick which tool you like to work with. All right. But one thing to note is that NumPy, when you're working on, large numerical data sets, like its performance is kind of better that way, meaning that it'll run your code faster when I say performance. All right, so now we get to load the data. So hopefully that's giving you time to save it where you need to and load it into your Colab. I'm going to change something up here as I feel I'm looking over here at my notebook and I'm not really looking at you guys too much. So I'm going to change that up real quick. Give me just a second. Okay. I think that's better. Whoops. There we go. Okay. Okay, thanks. So let me get back over here to the notebook. Thanks for bearing with me there. All right, so our first code block will be to load the necessary packages. Oh, let me back up really quick. I said I was going to remind you how to set up your system. So hopefully everyone had a chance to review the very quick 5-minute video on how you can manage environments with Anaconda. And what environments are ways to package all of your packages and your coding interdependencies together to recreate the exact environment you used to make your project. And it's best not to intermingle that with all the other things that you've used for other projects on your base environment. It's best to create a specific environment just for your project. And you can do that with Anaconda by using the conda create command. And once again, there's a video on the Women in Code playlist if you are not familiar with that. Hopefully we have enough people here that have done this before, but most importantly, get that specific project environment set up before you get going. So that way you can package that, with a YAML file. We'll get into that later, but share that with someone else. And that way, if they want to run your project, they can load the exact environment that you created that project in and make it run smoothly. Otherwise, you can run into issues with being able to reproduce the results or having errors or troubleshooting issues because there's some interdependency problem because the environment is not exactly the same. So it's a good thing to do ahead of time. Okay, so, oops, sorry about that. We'll save that question for the end because I think we have some standard responses to that. I just wanted to check the Q&A, make sure it was nothing important. Okay, so we need to import the libraries we need. We mentioned that we needed pandas and NumPy or one or the other. We're going to work with pandas tonight, but you can go ahead and run that cell. And basically, it's just easy as import the package you're looking for, and we're going to give it an alias. That way it makes typing easier when we're calling that alias throughout our code. Okay, so you can read in the data as we saved it over here in our Colab file. We're going to read it in, and you can read it in from the uploaded file here, or you can read it in from the URL with Kaggle. There's two options. We're going to read it in, but we're going to define the data that we're pulling in as a data frame. And I use DF as an abbreviation for data frame, which is not coding best practice, but it's actually pretty standard. You might want to name it something a little bit more particular, like maybe initial data frame or something to let you know this is your starting point. And so when we load it in, we're going to be able to take a look at it now. So there's a couple things you can do in pandas to help you review the data. You can use the info method, and every method has parentheses at the end of it. That's how you know you're defining a method. And then you'll be able to put things in the parentheses as you learn to code. And if you're familiar with Python, you know what I'm talking about. So the info method provides us the total number of entries, the type of columns, the number of null values. So null means missing values, or the amount of memory used for the data frame. It gives us all kinds of information, and it helps us understand the structure. The describe method is great for statistics. So if you want to get a snapshot at the distribution or the shape of the data set, that's important. And you can call describe on any data frame as well as the info method as well. And so if we want to see what our data looks like, we can just use, we established the data frame earlier as df. We can use df.head, and that'll give us the first 5 observations of our data in that table or data frame. And it just defaults to 5. If you wanted to put in another number here, it would give us more. Whoops. Oops, I didn't think I ran that one, did I? You have to run it. So that's the play button there. So there's the first 5 is a default. You can put in a number here that you want to see. But more importantly, let's take a look at the shape of it, which is another method we can use here. So once again, we notice that we have 17 features and 2017 observations. And why does anyone think that we have 17 there? Is there an answer that I have for that? Does anyone know? Because we said 16 before. And feel free to jump in. Yep, that's correct. Yeah, I'm seeing people saying unique ID, primary key, things of that nature. It's definitely related to database. It's your unique identifier, correct? So that's always going to happen. Next, we can look at the info. Did I run that? Okay, great. I need to run this here. And you can do that by doing df.info method. And like I mentioned, you can see the data type here. Integer means a numerical value. A float is a continuous number, so it's has decimal points in it. And then an object would be a categorical, and I brought that up earlier. It's a non-numerical value, so we call it categorical. And we can see just kind of what all the attributes are here. That's great. So we're looking for the non-nulls. So meaning that it's not missing. It is, in fact, has data in it. And we can see that nicely all of our observations are complete. We don't have any rows with a feature that's missing, so to speak, which is really rare in the real world. But mind you, Kaggle has a great data sets that kind of just let you plug and play, and you don't have to clean too much. So that's nice. We can see the name of our columns and then the memory usage, like I mentioned there. So describe was the statistical method we use to kind of get a snapshot of our distribution. And if I run this, we can take a look at the mean, the standard deviation, the min, and the different benchmarks here as far as our data goes for each one of the observations, even our target variable, which is kind of nice to look at. Okay, and even though we saw that there were no missing values here, another way to check that is to call the method of isNull values.any and the method any together, and you can see it'll tell you if there are any missing values, and we got a false, so that means we're good. We just double checked it. Missing values tends to cause a lot of problems and use the data a lot, and you have to figure out how to handle those, and we'll talk a little bit about that later. And there's a lot of different methods to doing that, and it's very scientific approach depending on what you're trying to achieve. So next we want to look for oh, here's just another way you can also check for nulls. You can sum them up as well to see how many. So I'm just giving you options here in the notebook. As you work through it, you'll kind of get used to the different things you can do. So we talked about null values. So if there are null values, which is something that you're going to come across in any data science project, you're going to analyze the pattern. So investigate the reason behind the nulls and see if it's random or systematic and how it's going to affect the outcomes of your project. You're going to want to remove missing data. So in cases of limited null values, you might be able to drop some rows or features with missing data. And this is very subjective. So you want to know, you don't want to drop too much of your observations because it's going to impact your prediction. You don't want to drop features that are going to be very important to your prediction, such as, specific attributes of tempo in the music or things that, typically make people like music, the way it sounds, that might really impact the project if we just delete it altogether and take it out of there. So sometimes dropping the nulls is not a great idea, but you can do it in limited situations with limited nulls. So you can do that with drop in a method. You can also impute values. So you can replace missing data with estimated values on available data, such as the mean. You can use the mean or the median or mode. Mean is probably the most common. You can use imputation techniques like using machine learning models to actually tell you what to impute in that missing null. So if you get more advanced, you can start using those techniques to kind of help you decide what should go in those missing values, which is really nice. You can use categorical placeholders. So you can use a known, something to that effect, and it really just depends on what's going to serve your purpose. Or you can use probabilistic techniques, such as Bayesian techniques, and that's a really more advanced topic. Okay, so another important thing to do is once you've established if there's missing values or not and how you're going to deal with them, you need to also check for duplicates because that could impact our outcomes a lot as well. So we can check duplicates here with the method duplicated in .sum. And we can see that there are no duplicates. And once again, that's another unique thing that's kind of nice. In the real world, it's not so clean and easy, but for our purposes, this works really nice. It lets us go through this quickly. So if there are duplicated values, what are you going to want to do for that? We're going to want to check those values, figure out which rows were duplicated, and verify if they are actually unique or not. One way we could do that is either by looking at the unique key. We can look at any other identifier features that might show us that it might be unique. There could be an error there. And then if it is indeed a duplicate, you're going to want to drop that. Someone said they got 5 duplicates. So it's possible the data has been updated since I saved the copy. So the data you downloaded might be different from the one that I downloaded. I don't think it should be. I mean, if you're still getting the same amount of rows or observations, the 2017, I don't know why you would have 5 duplicates, but that's interesting. That's something we could probably talk about maybe in the Slack channel, and maybe other people if you've gotten the same result. Okay, we're seeing other people with zeros. Yeah, maybe that's a good topic for the Slack channel, and maybe we can all kind of help you figure out why. That would be awesome. So go ahead and put that in the Slack channel if you haven't already, and I'll kind of help you figure that out. Okay, so
take a look at the Q&A section in the box, Q&A box. We've gotten a couple of questions come up.
Thank you. Sure.
One of the questions, somebody asked why some call twice. If you go up, I think the cell before this duplicated cell, we wanted to find out all the NA values.
No, I don't think it's actually needed. That might be an issue.
Yes.
Yeah, so it affects the way, it's not really needed, but affects the way the results are shown. So you can see what happened when I took it away. It just gave you a complete list of all the different features and the counts. But what I'm doing is summing it twice. So now I have a sum of sums. Hopefully that answers your question here.
And you get 0. So that gives you like the combined sum, you know.
Yep, the total.
The total, exactly. Someone else wanted to know that right now, for this example, we have numerical values, but what if we didn't have numerical values in the columns? What will describe return?
These are really great questions. It only describe only brings back the information from the numerical features. And so it's helpful because what we do in data transformation and feature engineering, which we'll get to at a later session, is before we model, everything categorical that we want to use in our predictions needs to be changed into a numerical value. And we do that through encoding and other methods. But eventually your data set, before it becomes, as it's becoming model ready and before we use it in the model, everything gets changed into numerical values. So that would be a good place, you know, you could use that then there too. However, there's so many advanced visualization techniques that might be even better to use than to describe. I just wanted to make sure that you knew that feature was there, that method was at your disposal. So if you wanted to take a look at your numericals, you could. And it's going to be useful whether, you know, depending on what kind of problem you're dealing with. Hopefully that answers your question. If anyone has more to add, certainly feel free to jump in. I know we have some advanced people on the call, which is awesome. So yeah, we welcome everyone's help to getting everyone up to speed. Let's go back down here. Check my time. Okay, we're almost at time here. And I want to make sure we have plenty of time for more questions. But what do we do after this? So today we're just taking a look at our data. We haven't started cleaning it. We kind of started talking about cleaning methods, such as checking for nulls, which we'll review next week as well, or maybe the week after. I think we're doing visualization next week and then cleaning. But we'll also look for duplicates, but this is just the very beginning of cleaning. So we've just taken a look at what our data looks like. We've got it loaded. We're getting comfortable with our collab. So what our next steps will be is EDA, which is visualization. And we have a great session prepared for you. A visualization wizard has definitely put together a great notebook for you to look at all the cool things you can do. So that's for next week. So what you want to do before you finish the session, and for any project you're going to do, you want to save your progress, right? Colab will save that for you automatically. It won't save your data. You'll have to reload it, but it will save your progress on your notebook. One thing that you should get in the habit of doing is saving your Python file, or your notebook file. So this is a notebook file here for Jupyter. And you can save it by going right up here and save or download. And you can pick which file type you want. If you're going to continue using the file in a notebook or an IDE that's running like a notebook web app or something, you're going to want to use the IPYNB. And that's for a notebook file. And this is just a Python file. So it's just like a script is what you would get. You wouldn't get the actual notebook with the cell blocks. But you're going to want to save a copy, save it to your local device. And that way, you know, if something happens with your Colab, you have a backup, or if you wanted to end up using your notebook that you made on Colab on a different interface or different IDE, you could do that. It's just a good habit to get into. And we haven't made much changes to the data. So another thing I would say too, is that if we'd made a lot of changes, like if we did find duplicates and we did find a bunch of nulls and we were changing that, What we'd want to do is save a new clean copy of the data. And we'll show you how to do that in the cleaning session. But it's something to think about in advance, because you're going to want to keep working on your project in succession with the most recent up-to-date clean data. So that's a consideration to have. We have some great questions. Let's go ahead and wrap up the session with some questions. I don't know, Chief, you want to read them off? You want me just to handle them?
So a number of people have asked about the particular notebook. So after the session, yes, we'll make that available to you guys.
Yes. So in about 2 or 3 days, we're going to load up the first session work notebook into our GitHub repository. Hopefully everyone got the link, and then that we can see the work that was done during the session to kind of fall back on. But that way you can kind of work with your own methods and kind of play around with your notebook ahead of time. And then you can check those in a couple of days. We'll post them on the repo in GitHub.
Then someone else is asking, that they would have liked to see live, I guess. It'd be really helpful if we can solve data for the null values and show examples of how you handle when you have null values in your data set.
Yeah, I definitely agree. It's a big piece of data cleaning. We will spend more time on data cleaning on the third session. However, this is a good point to bring up. Just for the essence of time, we kind of left it as it was, and we took advantage of the clean notebook or the clean data set they gave us initially. But it would be a great place for the Slack channel to talk about data cleaning methods and essentially how you would handle that. One thing we did mention here that I might remind you is the drop NA. Where is that one at? I know that I mentioned it here briefly. So if you found a bunch of rows of missing data, remember I said that dropping data is kind of the last resort, but that is one method on how we handle dropping rows, or not dropping rows, but dropping observations that have missing values. Well, same thing. Yeah, I'm confusing myself and you at the same time. I apologize, but yeah, so that's one option, and we can talk about it in more detail. We could probably post links in the Slack channel around that topic, because it is a very important one. It's a good question, and you definitely do want to see what that looks like. Because if we were to maybe impute some values or decide that, like, hey, we have hundreds of missing values for this tempo feature, that's kind of important. So what are we going to do about that? And most of the work with transforming and dealing with nulls goes into like conceptualizing and talking through the repercussions or the biases you're going to create for doing so. And it's a very it's kind of an involved decision process, and most of the work goes into just deciding which method you're going to use, basically. Once you figure that out, the commands and the methods you're going to use to do that in Python are really easy. So yeah, hopefully we can keep that conversation going in Slack. That'd be great.
Yep, we have 2 more questions, Lindsey.
Yeah.
Thank you all for sticking with us. I know we are over time, but I want to make sure that we get to all your questions. So we have just 2 more to go. Someone's asking here that as SQL skill is important for data science role, usually, can you please share some good resources that we can refer to in your opinion? Thank you. And it's interesting, actually, we had a session on SQL not long ago. We actually have a Slack channel for that. I don't know if it's too late for them to join this channel. Maybe if we can dig that up and put, if it's still, they can still join, they can find some resources there. Or Lindsey, you have some other ideas?
Yeah, absolutely. I'm going to put that link in the chat here for everyone for the SQL Slack channel. Oops, I think I might have put the wrong one in there. And copy. Hold on just a minute. Copy link. There we go. That's linked to the SQL channel in the chat, where we can bring the conversation about. But we did do a whole series, as she mentioned, and it's a 5-part series on beginning to end, advancing in complexity for SQL. And that's a really good one. We did that 4 months ago. You should be able to find that on the WWCode YouTube channel, and you can walk through it at your own pace. There's also tons of really great resources. Data Camp has really great SQL courses. Data Lemur is a really good one as well. It's hard to find free ones, but I think that's, once again, in the Slack channel, we can discuss good resources. But it is an important skill. I find it highly important. I think people glaze over SQL. I know I did at the beginning, thinking, oh, I don't know if I'm going to need this so much, but it actually is wildly helpful, because most enterprise organizations, They have everything on a relational database, and everything you're going to pull, all the ETLs you're going to do, which is extract, transform, and load, to get the data to where you need it so you can do this analysis and do this predictive work, requires you to pull the data from that database. And typically that's done with SQL. So it's really important.
Right.
Yeah.
Someone wanted to know, I think we can probably do this quickly, just do head to see the first 5 rows of the data frame. So someone's asking, can we please?
Let me scroll back up here.
5 rows of the
and
data.
You can see all.
Yes.
Yes.
So
and of course you can see more than that if you like.
Yes. So head usually defaults given the first 5 rows, but you can choose to see more in the data frame.
Yeah.
So the last question, somebody added this last question. Oh wait, so there's 2 more questions. Guys, I think after this next one, we might have to end it because we are over time. So somebody asked, this is for the Women Who Code group. Could we have a workshop or a series on GitHub? And I know one of the learning materials, the resources for this was actually a video on GitHub. So you can take a look at that, but definitely something that we can consider. I don't think we've had one a session on GitHub. Maybe we could consider doing a session on GitHub.
Yeah, I don't know that we do that, but we do keep all of our code base and all of the work that we've done for all the series that we produce on GitHub, the GitHub repo. So, definitely we can use that as a resource once we continue the conversation throughout the series. But mostly we use it as just a place to put our code base once we're done. Typically like it is used for version control and collaboration in the real world. I don't know that we've actually used it as a workshop, but that would be a great idea. And I love hearing ideas like that. So if you have more of a, I can definitely look into it, but if you have more of an idea of how that could play out, like how we could use it as a workshop, I've never seen that done, but I'm just maybe ignorant to that. So I would love to hear more if you want to elaborate on the Slack channel. I can't wait to see it.
And our very last question for this evening, or it may not be evening where you are, but for this session is, will there be like a hands-on data session training, data science training session from the basics? So I'm guessing the person, I don't know if you want to elaborate on this, maybe it was just a little bit too advanced for you. Would love to hear feedback, but someone's asking the hands-on session from the basics. Do you mean like where you have access to the collab while the session is going on, or maybe you can elaborate on that question, or Lindsey, if you really understand it, you can go ahead and take a stab at answering, but I'm not quite sure if they want something the collab being shared before and then they're working alongside, or was this too advanced for you? So if you want to clarify, you can. Otherwise, Lindsey, if you have an idea of what they're asking, you can respond.
Yes, if we can simultaneously code. My idea was we might be doing that. And then Women Who Code decided that we wanted to just place the code base after the fact, because sometimes you kind of miss what's going on. I see value in both of it. It's kind of a double-edged sword. I like coding along as well simultaneously, but sometimes you miss things, and sometimes it's good to just kind of hear it first and then work through it. So we can discuss that as an option for maybe the next series session. But as I think it is now, I think what we're going to continue doing it this format. I'm super sorry if that's not working out great for you. But I'll definitely bring it up to leadership and see if we can change that format, or if there's something more we can do. I'm glad to hear though that isn't related to like perhaps the coding language or something else that you're needing to catch up on. And if that is the case for anyone, definitely check out the prerequisite checklist on the repo and the playlist on YouTube. That'll help.
Fantastic. Thank you so much to everyone that joined today. Really appreciate you taking the time. Thank to our speaker and to all the volunteers, and see you at the next session in this series. Thank you, everyone. Bye.
Thank you.